Hello everyone, this is Aishwarya from Sri Venkateswara College of Engineering. I'm from 3rd SEM. My USN is 1VE22 IS003. In this video, I'm going to talk about digital design and computer organization. In that, Boolean algebra and logic gates. First, let us know what is Boolean algebra. Boolean algebra serves as a foundation for representing and manipulating logical operations within digital circuits. It enables engineers to design and analyze complex systems by using logical expression composed of binary variables and operators such as AND, OR, and NOT. Boolean algebra involves logical operators, operations like AND, OR, and NOT, which define how binary variables interact with each other. Truth table. Tables that enumerate all possible combinations of inputs and their corresponding outputs for a given logical expression or circuit. Boolean expressions. Algebraic expression composed of binary variables and logical operators used to describe the behavior of digital circuits. Simplification techniques. Methods to reduce the complexity of Boolean expressions such as Boolean laws, K-maps, and algebraic manipulation to optimize circuit design. Gate-level implementation, mapping Boolean expressions to physical logic gates like AND, OR, and NOT gates, which are the building blocks of digital circuits. Boolean algebra enables designers to analyze, optimize, and implement digital systems efficiently, ensuring correct functionality while minimizing hardware complexity and resource usage. Dual. Huntington postulates were listed in pairs and designated by part A and part B. One part may be obtained from the other if the binary operators and the identity elements are interchanged. This important property of Boolean algebra is called the duality principle and states that every algebraic expression deducible from the postulates of Boolean algebra remains valid if the operators and identity elements are interchanged. Basic theorems. The postulates are the postulates and theorems of Boolean algebra. Therefore, since the complement is unique, we have x complement into complement is equals to x. The theorem involving two or three variables may be proven algebraically from the postulates and the theorems that have already been proven. Theorems of Boolean algebra can be proven by means of truth tables. In truth tables, both sides of the relation are checked to see whether they yield identical results for all possible combinations of the variables involved. The algebraic proofs of the associative law and De Morgan's theorem are long and will not be shown here. However, their validity is easily shown with truth tables. Let's see what is digital logic gates. Digital logic gates are the fundamental building blocks in digital design used to perform logical operations on binary inputs to produce binary outputs. The basic types of logic gates include AND gate, OR gate, NOT gate, NAND gate, XOR gate, XNOR gate, and NOR gate. AND gate. Outputs true only when all inputs are true. OR gate. Outputs true if at least one input is true. NOT gate. Inverter. Output the opposite of the input. 1 becomes 0, 0 becomes 1. NAND gate. Output false only when all inputs are true, otherwise true. OR gate. Output false if at least one output is true, otherwise true. XOR gate. Exclusive OR. Output true if the number of true inputs is odd. XNOR gate. Exclusive NOR. Output true if the number of true inputs is even. These gates can be combined to create more complex logic circuits, allowing for the implementation of various digital functions and operations. The graphic symbols and truth tables of the gates are shown. Each gate has one or two binary input variables designated by A and B, and one binary output variable designated by Y. The inverter circuit inverts the logic sense of a binary variable, producing the NOT or complement function. The small circle is in the output of the graphic symbol of an inverter referred to as a bubble, designates the logic complement. The triangle symbol by itself designates a buffer circuit. A buffer produces the transfer function but does not produce a logic operation since the binary value of the output is equal to the binary value of the input. This circuit is used for power amplification of the signal and is equivalent to two inverters connected in cascade. The NAND function is the complement of the AND function as indicated by a graphic symbol that consists of an AND graphic symbol followed by a small circle. The NOR function is a complement of the OR function and uses an OR graphic symbol followed by a small circle. NAND and NOR gates are used extensively as standard logic gates and are in fact far more popular than the AND and OR gates. This is because NAND and NOR gates are easily constructed with transistor circuits and because digital circuits can be easily implemented with them. The exclusive OR gate has a graphic symbol similar to that of the OR gate except for the additional curved line. On the input side, the equivalence or exclusive NOR gate is the complement of exclusive OR as indicated by a small circle on the output side of the graphic symbol. Now let us see what is extensions to multiple inputs. Logic gates can be extended to handle multiple inputs by simply adding more input ports. The behavior of the gate remains the same. However, the truth table expands to accommodate the additional input combinations. For example, an AND gate with 3 inputs would have a truth table with 2 power 3 equals 8 possible input combination. Similarly, OR, NAND, NOR, XOR and XNOR gates can all be extended to handle multiple inputs in the same manner. Additionally, there are specialized gates designed to handle more inputs efficiently such as MUX multiplexer. A multiplexer selects one of several input data sources and forwards it to a single output. The number of input lines determines the number of possible input sources. Demultiplexer. A demultiplexer takes a single input and directs it to one of the several possible output lines based on control signals. Encoder. An encoder compresses multiple input signals into a smaller set of output signals, typically for data compression or error detection purpose. Decoder. A decoder performs the reverse operation of an encoder, expanding a smaller set of input signals into a larger set of output signals. These extensions allow for more complex digital circuits to be designed, enabling the implementation of advanced functionalities in digital systems. Let us see what is positive and negative logic gates. Positive logic gates interpret high voltage levels as true and low voltage levels as false. Examples include AND, OR, and NAND gates. Negative logic gates, on the other hand, interpret low voltage levels as true and high voltage levels as false. Examples include NOR and XOR gates. Both types are used in digital circuits depending on the specific requirements of the design. Thank you.